Next, we have the session with Munjal. Munjal, abhi thodi der pehle, before lunch, we had an AI panel and everything was discussion ho raha tha, and a lot of people were talking about ke models ko train kaise karte hain, ye kaise hoga, wo kaise hoga, and we lost a lot of question and answer and in between and everything. And but the core was कि भाई मॉडल्स को ट्रेन करना पड़ता है, कोई एक्चुअल इंसान जिसने किया हो वो अगर यहाँ पे हमें वो चीज़ समझाने की कोशिश करे, then it is going to be beneficial to all of us. So let's welcome Munjal. Yeah, he's here already. So huge round of applause for him, guys.
Thank you for generous introduction. So I'll not waste much of time in the introduction. I am currently working as a senior software engineer at NVIDIA, mostly working in AIOps, AI engineering, Gen AI technologies currently. So today's topic, which we'll be touching on, is Kubernetes Made Conversational, unlocking productivity with kubectl-ai. So how many of you have over here have used Kubernetes, or at least heard about Kubernetes? Nice, interesting to see that. And I hope most of you would be able to relate with this meme. Like this is a reality for everyone who is working in Kubernetes, or some of you who didn't raise your hands, you'll thank yourself later that you attended this session, and you'll be having all the things in your toolkit so that you don't have to end up in this situation. So let's be honest, when we first heard about Kubernetes, it appeared to be a solution to most of our infra-related problems, at least. We imagined ourselves to deploy applications very seamlessly. Our clusters would be running effortlessly without us doing anything. And we don't need to spend more time on managing the infrastructure, right? After all, Kubernetes comes with self-healing, auto-scaling, and all the other magical features, right? What could possibly go wrong? Then when we start working in it, we soon find ourselves juggling with multiple YAML files, deciphering that cryptic error messages, and often lost in the jungle of tools, with each tool promising us to make our lives easier. And what happens? Each tool has its own learning curve. And on top of it, integrating that in Kubernetes is altogether a different, brings together different sets of challenges, right? Be it experienced or be it beginners, this is a system which has humbled us all. For beginners, just to deploy application, you will feel that you require entire computer science degree. You need to know about a lot of things. You go to a blog or let's say YouTube tutorial, and each tutorial makes you feel that you don't know 10 other things. And soon you will find yourself drowned into ocean of acronyms, right? And for experts out there who have been working in Kubernetes for a long time, they would be able to relate. Like for example, you would be remembering many a times that you are spending hours troubleshooting an issue, and that issue is basically you missed some space in your YAML file, or that silly syntactical issue in YAML file. And also the classic one, let's say you are troubleshooting an issue and you struggle to find whether that issue is in the container or at the pod spec level or in the networking, and you are spending a lot of time troubleshooting. In fact, we heard in the session before lunch, right? Some 60% of time is spent in troubleshooting, right? So this is a reality. Now, let's say what if we can have some way wherein we can be more productive in our troubleshooting or managing Kubernetes, so that our whole experience of managing Kubernetes is a lot less stressful, be it for the beginners or let's say for the experienced people. That's where kubectl-ai comes in. So I hope now everyone has heard about agentic AI, right? Like we heard a lot about it. I hope that I can assume that, right, safely. So kubectl-ai is nothing but your AI agent, and this is specialized in managing Kubernetes. It's designed to make your experience with managing Kubernetes as simple as having a conversation. It's an open source project from the very own company which has created Kubernetes, that's Google. The way it does is using large language models, and what happens is LLMs basically translate users' intent, what users want, into precise Kubernetes commands. So gone are the days that you need to memorize your Kubernetes commands or go to Stack Overflow or like anywhere else to identify what command I need to run. And for that very sake, you don't need to go to ChatGPT or let's say Perplexity or something like that as well. Currently, it supports multiple AI providers. So you can use LLMs from, let's say, Gemini, OpenAI, Azure's OpenAI, Grok, or let's say you have LLMs deployed locally. You can use Olama or Llama.cpp. Also, for the safety purpose, there is approval mechanism. So for all the actions that this tool will be doing for creating or updating or let's say modifying any of the resources, it will first ask you for your approval and then it will be doing. Now let's try to see under the hood how kubectl-ai works. So the yellow box that you are able to see over here is all it is, with the green ones as its components. So the main brain behind this is AI agent. And what it does is mainly three tasks. First one, it tries to perceive the current status of your Kubernetes cluster. And secondly, whatever user asks in their request, it tries to process that and tries to understand what user wants to do. And third, it delegates, it determines what needs to be done and delegates those tasks to tools. Coming to the second component, that is tools. So tools, you can think of it as specialized functions. I'm sure you all are from the computer science background and you might have created some or the other functions, right? So tools, you can think of it as specialized functions. And if we go with a very like simple analogy of humans, if AI agent is the brain, tools are your hands. For example, right now after a wonderful lunch, you all will be, I'm not sure all, but many of you would be feeling sleepy, right? So what your brain will do, it will direct your legs to go to cafeteria and direct your hands to grab a coffee. Similarly, AI agent will direct tools to perform certain action. And these actions will then be performed on your Kubernetes cluster. Once the actions are performed, the feedback of it in the form of the state of your Kubernetes cluster, manifests, events, logs, that will be again fed into the AI agent so that it can ascertain that whatever action was taken, it can validate its results, basically. And there are three ways in which you can interact with kubectl-ai. One is using the CLI. So like if you are downloading the binary from their GitHub repo, then you can just simply run a shell script and you can simply call that binary and you can use CLI to interact with your Kubernetes cluster. There is another thing, this kubectl plugin. So essentially, if you are familiar with Kubernetes, you can register any CLI as a plugin. And like if you are using the shell scripts available from their official repo, it will register the CLI as a plugin. There is a second way in which you can interact with kubectl-ai, and that is through UI. So let's say you are deploying kubectl-ai as a Kubernetes resource. Let's say you want to run it as a pod, and you want to interact with it using some kind of service. So that's where there is a built-in UI. It's a very simple HTML UI wherein you can just ask questions and you can get the response back in the UI. There is another way also in which you can deploy it. So let's say for more advanced cases where you have multi-agentic workflow wherein you want some agent to interact with your kubectl-ai, then you can expose it as an MCP server as well. So what it will, for all those who don't know MCP here, it's a interoperable protocol for communication between different agents. And yeah, this is how it works under the hood for kubectl-ai. Now talking about tools. So tools, we saw that these are the hands which are actually performing the actions. So you can think of tools as the resources or those specialized functions which will extend the capabilities of kubectl-ai. Currently, kubectl-ai comes with just two functionalities, that is performing kubectl commands, and secondly running bash script. So bash script is mostly what I've seen is basically wrangling with the logs and all that. That's for what it is using. Now let's say you have got some advanced use cases where you want your Kubernetes manifest to be packaged as Helm chart. So for that, you can create a custom tool. Here is an example of a custom Helm tool. It's a very simple YAML config is what you need to have. So you can see that there is the name, that's Helm. There is a description. So this description will be used by LLM to understand that what capabilities this particular tool is bringing in. Then what is the command? Over here, it's again Helm. And in the command description, which is the fourth field, you need to provide detailed usage of individual commands. And this is how this is easy as it is to create a custom tool. Now let's see it in action. So first of all, to get started, of course, you need to install kubectl-ai. That you can do it directly from their official GitHub repo. It's an open source project. Secondly, to use LLMs, you need to generate API key from the corresponding LLM provider. So for all those of you who are starting, I guess, Gemini, basically you can easily use that in your day-to-day workflow. It's the free version as well. So for like a very day-to-day purpose, you don't need to buy that. That's what I have seen. The next step is to configure your kubectl-ai. So for that, there are three options. You can do it either using the flags in the CLI tool, either using the config file or using the environment variable. Over here, I have shown how you can do that using the config file. All it requires at a very basic level is the model name, LLM provider, and in case if you are using any kind of custom tools, then the path to that tool config file that we saw previously. And that's it, you can start using your kubectl-ai. Now let's see it in action. So what I've done is I've tried to run some of the commands on kubectl-ai before our session, and maybe we can then go through that so that we don't waste much of our time. So before starting or using any of the tool, of course, we should do check its help flag. We can see that what all capabilities it brings in. At a very high level, if you see, you can provide a path to your config tool config file. What kind of let's say if you are using some other Kubernetes cluster from deployed somewhere else, then you can provide the kube config file for that. If you are using different LLM provider, you can also provide LLM provider flag over there. Either if you are using MCP client, MCP server, you can provide that as well over here.
Right.
And this is very self-explanatory. Maybe if you would like to try out, you can download it and check their flags, help flag. Now, the way it works is, so right now I'll be showing you in the CLI mode. In the CLI mode as well, there are two ways. One is in the interactive mode, and the other one is maybe directly using the CLI. What we'll be using right now just for the demonstration is interactive mode. So for that, all you need to do is you just need to type kubectl-ai. Or if you would like to use the kubectl plugin, then you can ignore the hyphen in between. And the first question I'm asking to it is, what is the status of the cluster? And it identified that I need to run kubectl cluster info. So it is running that. And after that, it found out that I need to run another command as well, that is kubectl get nodes. It ran that, and this is what the response it gave. Oh, I'm sorry, this click is behaving weirdly, but I hope you are able to get the gist of it. Now, next, I asked it question like list down all the resources and their status in the demo namespace. What it did, it ran kubectl get all -n demo, and whatever response from that command is, it summarized that for us, so you don't have to go through the output. And this is the summary. Basically, we have got some pods which are crashing. There are some services. There is one deployment, and there is some replica set. So this is how easy it is to interact with your Kubernetes cluster. You don't need to memorize any of the Kubernetes commands. Now let's see second example, wherein let's say we want to create resources, or let's say update resources. So let's start with creating the namespace. So we can simply ask something like create demo app namespace. It ran a command. And now notice that this is a resource creation command, right? So it is asking for your approval. So once we approve that, it created the demo app namespace. Afterwards, we asked it to create manifest for Nginx deployment and expose it on port 80 in demo app namespace. You see, it came up with a deployment spec and a service spec. So you don't have to go to Kubernetes website, copy from there and paste it over here. It came right here for you. And then again, it will ask you for your permission to create. We gave the permission. Once it is done, then like if you notice, it's basically cluster IP service. Now, let's say I want to use it for dev testing and I want to like expose it to, let's say, node port and do the troubleshooting, right? So instead of running the command, I can simply tell it like update the service of Nginx deployment to type node port in demo app namespace. That's all it. You just provide your intention, what you want to do, and it will do it under the hood for you. You see, it created a service spec again for us, created a service for us, and that's it basically. And if you see in the previous prompt, I had done some typo error also. So basically, instead of TO, I wrote TP by mistake, and like it ignores all those typo errors as well. Now next, like let's say if you don't want to do kubectl get PO or something, and so you can simply tell it like get me all the resources and their status in the demo app namespace, and like it will run all the commands for you and give you the response. Now let's say next I would like to scale this Nginx deployment to 3 replicas. You can simply tell like scale the Nginx deployment to 3 replicas and add a liveness probe in demo app namespace. Now like this is one of the requirement which I have added over here. So let's see if it's able to do it. And we can see that it came up with again a new manifest with the 3 replicas. And also there is a spec for liveness probe as well. Again, it asked for the approval. We gave it approval. Once it is done, it again checked it whether this resource is already created by doing kubectl get deployment and Nginx deployment. Now, if you remember previously, we didn't write exact name of the deployment. For all those who are practicing Kubernetes, for doing log of any of the pod, you first need to do kubectl get PO, copy the name of the actual pod and then paste it, right? So you don't have to do that now. You just provide the name, and it's intelligent enough to understand that, yeah, I need to do basically like kubectl command for this particular resource. That's it for the resource creation. Now, talking about debugging the issue, troubleshooting. So let's say I have a demo namespace where there are 4 pods. One pod is in crashback loopbacks of state, and the other one is an image pullback of stage. Instead of us doing debugging at pod level, container level, or like describe pod or something like that, we can simply tell our kubectl-ai why are some pods in image pullback of in demo namespace. Then it will identify that I need to run whatever commands, like you can see over here, it ran it. For individual command, there is a reasoning as well why it ran. So for all of those who would like to learn how to debug Kubernetes, this could be an excellent tool as your companion. And once it ran a bunch of commands, it came up that your image basically is fault. It seems to be faulty. And over here you can see Redis :123. This is image. It's intentionally I kept it as faulty. Now let's see if it can update the image on the fly. So we can simply tell it that correct the image of Redis deployment in demo namespace in Redis to Redis :alpine. And there it is. You can see that first of all, it identified what is the actual name of the Redis deployment using kubectl get deployments. So you don't have to do kubectl get deployment, copy the name of that deployment. And after that, it ran the patch command. So for like a new one, Googling this patch command, updating it, it might take a lot of time. Everything is done over here. all you need to do is you need to use this tool. And yeah, since it was a resource updation, it asked for the approval. We gave approval, and yeah, it was able to update our image to Redis Alpine. And afterwards, let's say when we are checking the status kubectl get all in the demo namespace, we can see that Redis pod is now in the running stage. So fixing and troubleshooting done using kubectl-ai. You are not yourself running any of the commands. And also please notice that while debugging, we are not changing our terminals to use browser or something. Everything in just one terminal itself. And there is a last demo which I would like to show you is using the custom tool. So there is a tool called Trivi. I know like most of you guys who are into this particular space might have come across. Basically, it's for security scanning. So Trivi doesn't come built into kubectl-ai. You need to create a custom tool for it. And I have over here for this demo created custom tool. We saw how easy it is. I've just like written a bunch of like, again, this tool is basically also, I've asked Cursor to create for me and it has created it. I have not spent much time on it. And in kubectl-ai, you can then simply ask it, list down all the security issues and vulnerabilities present in the demo namespace. And yeah, there it is. You can see all the different output of the result from it. And since we are running out of time, I'll quickly touch upon my last topic, and that is K-test bench. So K-test bench is basically, yeah. So let's say there are a lot of LLMs out there, right? So which LLM to use? So K-test bench, you can think of it as a tool to assess performance of different LLMs on Kubernetes related tasks. So there are some 15 to 20 Kubernetes related tasks ranging from resource creation, troubleshooting, and handling misconfigurations. And yeah, you can use this tool to identify which LLM you should use in your workflow. And this is a summary of the K-test bench, basically for all the Google models, but likewise you can create it for any of the LLMs that you are using. That's it, folks, from my side. We are ready to take questions if you have got time. And here is my handle if anyone would like to connect on this, or let's say on AI engineering, AIOps, DevOps side. Thank you.